Course 3, Lesson 69 and 70. Both are dealing with direct variation. So first of all, let's look at some vocab for direct variation. First, constant of proportionality. We show this with a k, and this is just a constant multiplier. In other contexts, this is just the slope. And that's really all it is here. We're saying how much are we going up by or down by constantly. The dependent variable, this depends on what we put into our equation with the independent variable. Direct variation, this is the relationship between x and y, and it is constant. We can show it with an equation y equals kx. And independent, this determines what's going to happen to the dependent variable. So when we look at a couple other things about our equation, we still have that k as our constant of proportionality. K cannot equal 0. Because if you can imagine, if I put a 0 into this equation, I just have y equals 0. Well, that's just a horizontal line through the origin. That's not direct variation. And just like our other equations, like y equals mx plus b, y and x are just variables. So we can know that we have direct variation. It will look like two things on the graph. Number one, the graph goes through the origin and it's a straight line. So the two big things on the graph that show us that it's direct variation. So it goes through the origin and it's a straight line. Second, the equation can be written in the form of y equals kx. We have that constant of proportionality that says how much we are increasing or decreasing by. So this is direct variation. So if we look at some of these and try to write some equations for them, if we have something like total pay equals $12 times the hours worked, we would say, well, the hours worked, that's independent from anything, but the total pay is dependent on how many hours I worked. And 12, it seems, is constant. So we could actually show this as y equals kx. Our y is what typically shows our dependent variable, and x is independent. You can think about when we have an equation, in this case we have y equals 12x. We would, in this case, choose x's to figure out what the y's are. We wouldn't typically choose what the total pay is to figure out how many hours worked. Typically we say, how many dollars am I going to make if I work 0 hours? 1, 2, 3, 4. So it is our independent variable because that one is what we're choosing. Similarly, miles traveled equals 60 miles per hour times the hours traveled. Once again, the miles traveled depends on how many hours I travel, so we can show this as y equals 60x. And perimeter equals 4 times the side length. The perimeter depends on the side length, so we can show this equation as y equals 4x. 4 is what is constant, because we always have in a rectangle 4 sides. Okay? Or in a square, 4 sides. So when we think about direct variation, what we're saying is that as one value increases, so does the other. As one value decreases, so does the other. Rather than a different type of variation that we will soon talk about, inverse variation, and this is when one increases, the other decreases. They are inverse of each other. So, when we do this, we have our equation, y equals kx, and how we find k is this. We take our equation y equals kx, and let's say we want k. We divide by x on each side, and we say k equals y divided by x. If you want to think about this in another way, I said earlier that k is also the slope. Well, y here is representing the rise, and x is the run. And we also know that the origin is always on my graph. So I can say from the origin to my point, I want to find the rise and the run. That's k. That's my y divided by x. So just remember, if we have a different k, it's going to look like a different thing on the line. So a higher k value, like k equals 3, it has a larger slope. Whereas k equals 1/2, smaller k value, smaller slope, it's a shallower slope. Alright, so which of the following is an example of direct variation? Okay, and we have a taxi company charges $3 to start the ride, plus $2 per mile. Well, if we think about this, $3 to start the ride. That means that even if I don't go any miles and I just get in the car, I'm going to have to pay $3. That means that this is not going to start at the origin. It's actually going to start at 0, 0,3 and go up from there. So this is not direct variation. How about the area? The area of the square is the square of the length of its side, which means I could show this equation as area is the side length squared. Well, when I do that, and I can plot a few points, and we will in just a second, I will end up getting something that is not a straight line. This means that this is not direct variation. And we can also see that with that s squared. It doesn't follow the pattern of kx. And lastly, the perimeter of a square is 4 times the length of its side. Well, we did this one earlier, and we said perimeter, or y, equals 4s, 4x. And so yes, this one is direct variation, because it will go through the origin, it's a straight line, and it follows the equation y equals kx. So let's look at some of these individually one more time to make sure that we have this right. So first, write our equation. A taxi company charges $3 to start the ride plus $2 per mile. So we can say the total amount is the $3 to start the ride plus $2 for every mile. And we're going to plug some values into the chart for 1, 2, 3, and 4 miles. So we can do that and say, okay, for 1 mile, I'm going to be doing 3 plus 2 times 1, which means I have 3 plus 2, which is $5. 2 miles, so 3 plus 2 times 2, so we have $7, $9, and $11. Okay, and we can say, all right, let's make sure that we do not have a constant, and we're going to be doing that by doing, well, x is our miles, my independent, y is the dollars, my dependent, so we do y divided by x, dollars divided by miles. So we have 5 divided by 1, 7 divided by 2, 9 divided by 3, and 11 divided by 4. None of these are the same, so we have no constant. So this is one way to prove that this is not direct variation, because we don't have a constant ratio here. There's no constant. Okay? And then the area of the square is the square of the length of the sides. So when we do this, we're going to say, write an equation. So we have area equals side squared. That's how we would find the area of a square. And let's see, side squared, so we get 1, 4, 9, and 16. I'm just squaring the side length. And once again, our constant here, we have 1 divided by 1, 4 divided by 2, 9 divided by 3, 16 divided by 4. It ends up making a nice pattern, but since these are all different numbers, we have no constant. So once again, this is not direct variation. And our last example from before, the perimeter of the square is 4 times the length of its side. Well, we said we can write an equation of perimeter equals 4s. So we get 4, 8, 12, and 16. I'm just multiplying by 4. So our ratio, we have 4 divided by 1, 8 divided by 2, 12 divided by 3, and 16 divided by 4. In all of these come out to be just 4. So we do have a constant. K is equal to 4. Our constant is 4, just like we thought before. Okay. So if we were to graph all of these, and we'll do them in different colors, our first one, if we graph all of those different parts, we will get some dots like this. It's a straight line, but it does not go through the origin. Okay, and then our s squared is going to be something like this. Alright, once again, it does go through the origin in this case, but it is not a straight line. And lastly, our perimeter equals 4s. We will have right here, okay, something like this. And so yes, it is a straight line. It goes through the origin. It follows the equation pattern. So yes, this is direct variation. Okay? And this is an example that you can try to see, do I know what it looks like to have a constant? Does it go through the origin? Does it follow that straight line? You can try this one on your own. Now let's look at lesson 70, because lesson 70 is looking at some of these direct variation problems again, and just some more kind of word problems. All right, so we'll do this pretty quickly. So when something varies directly, it means we have a constant ratio or a constant number we are multiplying by in order to find the next number, just like we saw in lesson 68. So when things vary directly, they are proportional. So in this case, we have the number of CDs and the price. So find the constant. And in this case, we see that the constant is 15, because all of these ratios are 15 divided by 1, 30 over 2, 45 over 3, 60 over 4. All of them are 15, meaning every CD is worth $15. Quick break for a second here. All right, let's keep going on looking at these. So the amount Ellen charges for banquet food varies directly as the number of people that attend. If she charges $780 for 60 people, how much does she charge for 100 people? Well, the thing is, we actually know that this varies directly. We don't have to prove that. So the first thing we need to do is find the constant. Well, to find the constant, remember, we need to do y divided by x. Well, the y is always my dependent, and the money depends on how many people. So I would say 780 divided by 60. Well, when we do that, $780 divided by 60, we see that it looks like $13 for every person. Okay, so we have found the constant. It's $13 for every person, which means we write an equation. So we say y is equal to 13x. So if we solve for 100 people, x is our people, so we say y equals 13 times 100, or $1,300. That's how much it's going to cost for 100 people to come to this banquet. Okay, and how about this one? Driving at a constant speed, the distance Maggie travels varies directly with the amount of time. If she drives 75 miles in 1.5 hours, how long does it take her to drive 100 miles? So find the constant. Well, the miles depends on how much time we take. So if we have 75 miles for 1.5 hours, we will say, well, we need to do y divided by x, so 75 divided by 1.5. And that gives us 50. Okay, what we're saying here is we are going at a constant speed of 50 miles per hour. And so we write an equation, we say y equals 50x. So for 10 miles, well, we would say 50 times, oh, not 10, it should be 100. So we have 100. So we are going to go for, let's see, oh, sorry, it shouldn't be, of course, we're not going to put it in how many hours. That would mean that we're going 100 hours. That would be a lot of distance. We put it in our y value because that's how many miles we are going. So we do 100 equals 50x. And we solve for how many hours by dividing by 50, and we say x is equal to 2. We are going 2 hours in order to go those 100 miles. Okay, we'll just do a couple more examples. There were 23 people in line in front of Dahlia, I don't know how to say it. 3 minutes later, there were 18 people in front of Dahlia. How long will she wait to be helped? So with this one, what we're saying is this line is going at a constant rate. Okay, that's what we're kind of implying here. And if at 0 minutes, there's 23 people, after 3 minutes, there's only 18. Meaning that we've gone down 5 people for every 3 minutes. So if we take that constant and do minus 5 over 3, okay, looking at how much we are changing, we can say maybe we can continue this pattern and say for 13 people, she'll have to wait a full 6 minutes. For 8 people, that'll be 9 minutes, okay, and so on. But how do we know for sure when we get to 0? Okay, so we say, all right, y is the amount of people. So if I create an equation, y equals -5/3 x, well, she starts at 23. Okay, this is constant, but it's not. This is constant, but it's not necessarily direct variation. We can still figure out how long she'll wait to be helped, because we're starting at 23 people, and we're trying to get to the 0 amount of people. Okay, 0 equals -5/3 x plus 23. So if we do that, -23 equals -5/3 x. So we multiply by -3/5. So what we're going to do, we're going to multiply out, and we say -3/5 times -23. So we say that's a positive 69 divided by 5. So 69 divided by 5, it's not going to be a full minute. We get 13.8 minutes, okay? So we can see how we can also go down with these direct variations. It's a little bit harder when we don't start at 0 at the origin, but we still can get an x value of how many minutes it takes, okay? All right, the distance a coiled spring stretches varies directly with the amount of weight hanging on the spring. If a spring stretches 2 centimeters when a 30-gram weight is hung from it, how far will it stretch when a 75-gram weight is hung from the spring? So let's find the constant, and in this case we do have direct variation, because with 0 amount of weight, we will stretch 0 amount of inches. So if we then take my 30 grams of weight, we will stretch 2 inches. So it all depends on that, how much weight we have. So if we have my 2 over 30, that's saying that we have 1/15. Okay, for every 1 gram of, for every 15 grams of weight, we will stretch 1 centimeter. Okay, so if now we have 75 grams of weight, well, this is just proportional. That's what our direct variation is. We have constant proportionality. So if we say, all right, well, 15 can go into 75, well, that happens 5 times. So we would say this would stretch 5 times. Or we could even set up an equation and say y equals 1/15 x. And we say for every amount of weight, in this case 75, we're going to multiply by 75. And we do see that y is equal to 5 centimeters. Okay, that's how much it's going to stretch. Okay, here are a couple more examples that you can work out on your own using direct variation. All right. And I hope this is helpful for your homework and for studying.